Now we have a fairly good idea about our x and y variables. Our x variable is present in the form of 2D array of 28 into 28 pixel intensities, where each individual pixel intensity lies between 0 and 255. And since we are going to use gradient descent to compile our model, we need to normalize this pixel intensities. By normalizing, I mean we have to restrict this pixel intensities between 0 and 1. A very simple way to do this is by dividing all the pixel intensities by 255. So 0 will remain 0 and 255, which stands for completely white pixel, becomes 1 and so on. So to normalize, we can just divide our extent full data set by 255, and similarly we have to normalize our test data set as well. So for test also we are dividing all the pixel intensities by 255. This normalization is different from the normalization we generally do for machine learning algorithms. Since here we know that all these values are on an absolute scale of 0 to 255, we can directly divide it by 255. But for general machine learning databases, we don't know the absolute scale. So we generally subtract the mean from these numbers and divide it by their standard deviations. But that process is not needed here, since we know that the pixel intensities lies between 0 and 255. So here we can directly divide it by 255. And one thing you can notice is that we are not dividing it by 255, we are dividing it by 255.0. That because we want the final output in the form of floating numbers between 0 and 1. If we divide it by just integer values of 255, so since the intensities are integer value, there might be some cases with some Python version where we get the output as integer. Since we want the whole grayscale between 0 and 1, we have to use 255.0. With recent Python version, you don't have to do this, but to make sure that the code is compatible with all other Python versions, it's better to divide it with a floating number so that the final output is in the form of floating number between 0 and 1. We'll just create this. We are calling our normalized data sets as x underscore train underscore n and x underscore test underscore n. As I told you earlier, our trained dataset is of 6000 observations and our test dataset is of another 10,000 observations. We will further divide our trained dataset into training and validation sets. We will use the first 5000 observations as our validation test and next 55,000 as our training dataset. So to do that, we can just divide it using this simple operations. We are saving our 0 to 5000 data sets into X validation and from 5001 to 60,000 into X train. Similarly, we have to do this for our Y dataset also. We are saving first 5000 observations into X validation and next 55,000 observations into Y train, and our X test will remain the same. So we are just saving our normalized data into X test data. So just run this. Now we have three data sets. First is the validation set of 5000, then the training set of 55,000, and then another data set of 10,000 observations in our test data set. We will be using train dataset to train our model. We will be using validation set to optimize the performance of our model. And then after tuning all the hyperparameters, we will be using test dataset to evaluate the performance of our model. To view the values of this dataset, you can just call the dataset. You can see now the values are between 0 and 1. Just look at the first value. Here you can see there are some values which are between 0 and 1, and now our data is normalized. In the next lecture, we'll look at different methods that are available to create neural network using Keras. Thank you.